So in this question, I have ABC, which is a right-angled triangle, and then I'm given the diagram below, and I'm asked to work out the size of the angle ABC, given my answer correct to 1 decimal place. Now, the angle ABC is going to be the angle between the sides AB and BC, so this angle that we have here is what we're looking to find. Now also I'm noticing here that I have 2 side lengths of the triangle, so I have this length here which is 7, and then as this is a right angle triangle, I have the length opposite the right angle, so I have the hypotenuse of the triangle here. Now I'm thinking that I've got 2 side lengths and I'm looking to find an angle, and also I have a right angled triangle. So what's kind of springing to mind here is the use of trigonometry. So if I were to label these sides up, kind of linking to this angle here, this side CB is going to be the side that's adjacent to this angle, as it isn't the hypotenuse, so this is going to be the adjacent. And then AB is the hypotenuse of the triangle, so I can label that as H. Now if I think of SOHCAHTOA, I have A and H, so Ka of the SOHCAHTOA, which means that I need to work with cos. So cos theta is equal to A over H, and this here is the angle theta that they're working with. And I can sub my values in, so cos theta is equal to the adjacent, which is 7 centimetres, over the hypotenuse, which is 11. So theta is the inverse cos of 7 over 11. And if we calculate that using our calculators, we get an answer of 50.4788 degrees. However, the question has asked for our answer to 1 decimal place, so I can round that to 50 point, and then here we have the 7, which means that the 4 is going to round up to 5 as 7 is greater than or equal to 5, so 50.5 is the final answer here. We'd get the first mark for kind of working with cos here, so the cos of theta is equal to 7 over 11, that gives us the first mark, and then the second marks for the correct final answer of 50.5 degrees. Now for the second part of the question, I'm told that the length of the side AB is reduced by 1 centimetre, the length of the side BC is still 7 centimetres, and the angle ABC is still 90 degrees. And we're asked whether the value of the cos of ABC will increase or decrease given a reason for our answer. So if I have a look at my triangle and label up the new side, so AB is the hypotenuse and that's been reduced by 1 centimetre, so 11 minus 1, this is now 10 centimetres. Now if I want to find cos of ABC again, I need to substitute that in, so cos of theta or cos of ABC is equal to the adjacent over the hypotenuse. Again, the adjacent is going to be the 7, and the hypotenuse has gone from 11 to now 10, so I now have 7 over 10. Now I need to determine whether this means it's increased or decreased. Before we had 7 over 11 for the value of cos of ABC, and if I have a look at these, we know that 7 over 10 is going to be greater than what we had before, which was 7 over 11. So therefore, cos of ABC has increased due to this change. So we just had to do kind of a small calculation here, comparing our result to what we had before to get the mark for this part of the question.